Okay, so it's the first 100 hours and I want to keep it super, super simple. So if it seems a bit boring and basic, hopefully that's good. It's just about reinforcing what I learned and how I learned. Alright, so I'm assuming you have like zero knowledge of computers, roughly. Like you know the basics of it, but we're going to treat you as a complete beginner. So you'll know what a hard drive is, you know what a power supply is, you know what a motherboard is roughly, you know what a CPU is. Well, not you don't know what it is roughly, but you understand it's like the brain of a computer. So I've learnt more about programming as I did it with C programming, so I kind of get the basics how the CPU works in detail. But one concept I'm wanting to work out as a beginner is abstraction. Like you are going to come across this word so many times, and it's kind of useful. So let me just hit you with it. The process of removing detail from a representation is called abstraction. You've seen a car drive and you've seen a plane fly. You probably don't know how it works specifically. You probably understand plane goes really fast and then it moves because of wind and uplift and all that kind of stuff. Or car, you press accelerator and then accelerator ignites the fuel makes the pistons move, and like what the hell is this? You know, I don't quite understand this. As a beginner, you're going to see all these areas bit by bit, but what I want you to focus on is there is a car. I'll draw it right now, really badly. Here's your car, boom. Wheel. All I want you to care about for now is accelerate and brake. Press accelerate to move forward, press brake to stop. That's it. That's all we care about right now. As you learn these concepts, you can put more and more together to understand a full area. And that's kind of how things go. So for the first 10 hours, you're doing your basic maths, your additions, your subtractions, your multiplications, your divisions. Like the analogy is, this makes up most maths that most people do in their lives, you know? And you're learning the programming equivalent of add, minus, divide, subtract. And for me, in the first 10 hours, that is a loop, an if-else statement, basic syntax. Let's jump over to the code now. So again, everyone's seen this code, hello world. I asked the computer to print out this statement, hello world. It could be hello sham. But right now, you're interacting with the computer in a way you've probably never done before. So let's just say your hello world is my addition. I use a hashtag to block out a comment. Okay, we've done hello world now. We're going to have to move to a bit more complicated things, but just bear with me, you probably understand this. So right now I need to import the random function, import the time function, random number, print random number. So what am I doing? Again, this is a more advanced concept. When the computer is using a random number, it has an internal clock and it goes to the clock, tell me the time in seconds, and then I'll do some math on that to get a random number. So there you go. Give me a random number. It's given me 20. Let's run it one more time because the time in the clock has changed. You'll give me 81. So a little bit advanced for a complete beginner, but hopefully you get the idea. Now, why does that matter? Okay, I want to say, let's have a number called x, a variable called x. X is equal to 0. And then if random number divided by, oh, I don't need x. Sorry about that. If random number we have earlier is divisible by 2, let's say it's raining. So take an umbrella. If the random number is not divisible by 2, so if it's odd, it's sunny. I used sun and rain and even and odd for a quick example, you know. So yeah, our random number is 18. So it's raining, therefore take an umbrella. This is the next thing. If else. If state A, if state 1, do action 1, do action 1. If state 2, do action 2. Yeah. You could say if state 1 do A, if state 2 do B. You could also write if state 1 do action A, if state 2 do action B. You know? if you see a pattern of head, if you see a crown on the coin, your heads, if not tails. Bad example, but get through this. So now I'll say we've done our subtraction. Pretty super simple. Subtraction. Next, we're going to move on to loops. We're so close to being done now. Okay, boom, 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 and let's block you out. 1, 2, 3, 4, 5. Okay. So we're creating a loop. So I've created a range, an array now, which is just one block of contiguous memory. So when you see array, we talked about parts earlier. Computer has memory, so we'll call it RAM. An array is just one set of bits in RAM that are like all in a row. So you've got this bit, this bit, this bit, this bit. That's an array. Simple. All right. Again, I'm throwing a few concepts at you that are easy, but just think like it's like an Excel table all in one row, Okay, so we have a range from 1 to 10. The square of 1 is 1, the square of 2 is 4, the square of 3 is 9, the square of 4 is 16, all the way to 10. And again, super simple examples, but this can go all the way to 1,000,000, 1,000,000,000, depending on how much space and compute your power has. Okay. So now we're kind of got our last, I wouldn't say infinity stone because that reference has been used, but now we have our division. Yeah. Okay, and then the last kind of concept I kind of want to talk to us about is just our scanf. So what we've been doing now is we've been interacting with the computer as itself in a way, but if a person like me or my mum wants to come here and do something, let's say she wants to print a word and find the reverse of that word. Why is it not printing? Boom, reverse text. Run. Oops, that's a loop, my bad. There we go. Oops, this is also a comment. My mistake. Put in some text. Hello, my name is Sham. And you see the reverse now. This will be our division, okay? So right now we've learned 4 really super basic concepts. The loop, so the if else, the scanf, and what's the other one? So basic, I can't remember now. Hello, if else, division. Well, we learned like 3 areas which are kind of key. And I want to kind of say super basic stuff. First 10 hours, you've learned your basics here. And now you can apply them to harder and harder problems. So one project I did was a Pokemon script where I just say, okay, how many times do I want to move left to right? And I said 20 times. You can see him just move by himself. So that is taking all those 4 parts we learned, 3 parts, if else, loop, scanf function, get input, to create a working code in an example. Super simple. Hopefully you're still getting there. And if you're not understanding it, I'm not saying simple to say it's easy, I'm just saying reasonably it's your basics, So as you see, he moves up and down, that equivalent to 1 step. 1 step equals 1 XP point, Pokemon gets XP point. I can do this game grinding without doing anything. Right, so I'll just show you here. This is C code, it's different to Python, but basically move left, there's a loop here, move left, move right, move left, move right, for the amount of times you submit grind. So I'll say, hey, I'm the computer, user, how many times do you want to grind? User will go, okay, I want to grind 10 times. Okay, give me 10, I'll take 10. I go to the code, hey, the person wants to run this function 10 times. Left, right, left, right, left, right, left, right. We do it. And then we move on. Pretty simple stuff. A function would just be, how I explain it, a set of code by itself that doesn't have to run in the main, which is the main thing here. That will just do a certain set of instructions, So you could have function reverse, function this. So for example, it's a bit more advanced concept. What you can do is you can maybe take a function from the random memory here, and you could have it stored in the hard disk, so I can create my own special function for Sham. I like to wake up and have red light in the morning in my house, but I only want it for myself. I'll create a function, save it in my computer, and that's good for me. I'll talk about it later. It's like not that big a focus right now, but yeah, as you gradually move on and on and on, you start to have to apply functions. You start to have to apply all the concepts you've learned in a much higher level of understanding. So let me give you 2 or 3 more examples and kind of explain why. We talked about the array. There are other data structures you have to use, but as a beginner, I don't want to bother you with them too much. They're more important towards the last stage of things. What I want to stress is how my journey went. I just went from doing my basics to gradually doing my basics better to learning some more things now. So I went from, you know what, I now understand the brake, the accelerate. We don't need to talk about it. Now let's talk about the steering. Let's talk about the indicators. Let's talk about the clutch. Let's talk about the petrol. All these things come as one by one. So imagine learn first level, boom. Move to second level, boom. Move to third level, boom. You keep going to get to the very top. And it's hard to say you complete an area ever, but I'm saying once you get past, like, let's just say a few basic things, you kind of know everything, you know? It sounds very, very basic here, but once you know these things, you pretty much know all of programming. It's just how sophisticated do you do it. Like a lot of maths, again, as I said before, is just this, but much, much more advanced. Alright, so what do I mean by this? This was my basic Pokemon code, and it's in C, so it's a bit different. This is a Sudoku solver code I've done in C++. You can see this is much more challenging, uses a lot more things. It uses a multi-dimensional array, it uses depth first search, it does all this stuff, you know, so you can see how challenging it is. And it's not the right video to explain it, but there are some tutorials about what I've done later down the line. I'll just quickly go to this one more time. Think of it, a normal array, let's call it array 1, is one dimensional, so it's kind of like just this. The Sudoku array I used is a multi-dimensional, so I think it was a 9 by 9 by 10, so this array is more like this 3D structure. Boom, boom. It's basically this thing, really long thing in this form. Okay, so we're at hour 0. We've mastered our basics. As we're moving up, we're doing our basics more. We get to a harder project now, like my Pokemon, my Sudoku, but we're still doing the basics. One thing I want to stress about programming is, let's see if we got this. You never lose your fundamentals. So there is no universe where I get any of these basic, like primary school questions wrong. 5 plus 3, 8. 7 plus 2, 9. 9 plus 4, 13. 8 minus 3, 5. 10 minus 4, 6. 6 minus 2, 4. 3 times 6. 3 times 2, 6. 20. 14. Last one is 2, 3, 5. Alright. I know that sounds so childish and boring, but that is your basics. However, these questions are based on your fundamental understanding of these. This is just this built up and applied a lot more. So differentiation will have 3x to the power of 2. So what I want to do now is, I'll change color now so we can make this simple. We want to take the index power, we want to multiply it by the, I forget what's called, the polynomial or this. So the power is multiplied. First function multiplied right here. So we now get 6. 6x to the power of 2. Our next step now is we want to take this and minus 1. Okay? So we now get 6x to the power of 1 or 6x. That's the first part of this question. But you can see we've had to combine two of our basics. A addition, sorry, a multiplication, and then a subtraction. We've done two of our super basic concepts, put them together as a higher level question. Okay, and we go to minus 5x now, so I'll write 5x to the power of 1, which is this one here. 5x is the same as 5x to the power of 1, so what we do again, we do 5 multiplied by 1 equals 5, and then we've got 1 minus 1 equals 0. So we now have 5x to the power of 0, and then we're left with our answer being 6x minus 5. Again, when the number has no x, it just goes to nothing. You could write this as 6x to the power of 1 minus 5x to the power of 0, but we don't need to write the x to the power of 0. Okay? You may not know maths differentiation, but going from like primary school level to like a PhD in maths, all you've done is take these concepts, move them along the line. Here's another one now. 3x minus 7 equals 2x plus 5. Okay, I want to group the x's together. So this is a plus 2x. When our friend jumps across the equal signs, it becomes a minus 2x. So we now have 3x minus 2x minus 7 equals plus 5. Okay, I'm going to take our minus 7 friend, move it across now. So we got 3x minus 2x equals 7 plus 5. So I've got a minus, a plus, and I've had to swap them twice. You could say I've times it by negative 1 if you want to, so I've used multiplication. So 3x minus 2x equals x. 7 plus 5 equals 12. I think x equals 12. I should really check this, but I'm just in a rush to kind of just explain the example to you. Right. So here you've seen what we've done in this. You've learned your basics. You really have just learnt your basics right now. And in the first 100 hours, you're just mastering it. You're Mr. Miyagiing it. Cloth on, cloth off, cloth on, cloth off. Do that a million times, and then we'll move on to roundhouse kick, roundhouse kick. Once you learn your basics, once you know how to use these properly, because the for loops, the while loops, there are so many ways to use them. I'm just giving you a quick example. That in my Sudoku solver, you can see for loops here, for 1, for 2, for 3. I've done a loop within a loop within a loop. Once you learn to master this, once you learn how to use it in the right context, you go and build you go and build much harder, much more complex coding challenges, which is how things go. So yeah, that's really how the first 100 hours went, you know. I want to stress, in the beginning, super easy. You're always learning. But as you kind of, the longer you spend, the more difficult problems get, you know. Because you could stay here and just do move left, move right, move left, move right, but that's probably not going to solve the bigger challenges. But I'll say one good thing about 100 hours. What I could do about like hour 50 is I could look at any game I want to play and say, oh, I can see some patterns in there now. So that's really been my take on the first 100 hours. Hopefully you found some value from this. I know it's super basic, but like I said, I want to stress to you, you learn the basics very quickly, but you spend a lifetime mastering them. And anything complex is just loads of basic things put together.